Hello, everyone. We are Group 10. The topic we are going to introduce is AnimateQR Aesthetic QR Code Video Generation. This is our content. Let me briefly introduce our problem setting and our idea. Traditional QR codes are functional and convenient for a lot of situations, but it seem boring. So recently, a bunch of works dive into making QR codes to be more stylish and pretty. There are some demos of previous works. They are using different generative models and optimization processes to generate the stylish QR code image while maintaining their scannability. So we are thinking that can we make QR codes alive? Animated QR codes in the past usually just add a video background or create some basic animations manually using the original QR code. However, these approaches don't really look natural or visually appealing. There's our methods. Before discussing our method, let me first introduce how we generate the video. We use Animate Diffusion as our video generator. Animate Diffusion disentangles the appearance and motion of video data. It builds upon pre-trained 2D diffusion models, learning motion features through a motion module, which is implemented using a temporal transformer. The main feature of this method is its ability to separate motion features, enabling users to integrate the trained motion module with any pre-trained 2D diffusion model. This allows users to work with different styles of pre-trained weight, offering more flexibility in application. Moreover, Animate Diffusion supports the addition of various 2D plug-and-play modules, such as LoRa and ControlNet. This functionality makes it easy to produce videos in a wide range of styles. The easiest way to create a QR code video is to add a pre-trained 2D QR code ControlNet to Animate Diffusion and use a QR code video as input, but the results of using Animate Diffusion with ControlNet are not ideal. We observed two main issues with this approach. First, the generated QR code has poor scannability, making it difficult to scan. Second, the motion quality in the video is inconsistent with noticeable flicker effect. Our key insight is that these problems are caused by the rigid constraints of the QR code pattern. There is an inherent trade-off between the quality of the video and the scannability of the QR code, making it challenging to find a balance. Our main idea is to explore how to relax the constraints while maintaining the scannability of the QR code. Our method, AnimateQR, builds upon the previously mentioned key insight and adopts a two-stage pipeline to generate QR code videos. Since the rigid constraints of the QR code pattern significantly impact video quality, we first use Animate Diffusion to generate a video without QR code constraint. Then, we apply a traditional transformation method to convert this video into a QR code video, ensuring it maintains the overall contour appearance of the original video. With this less constrained QR code video, we feed it into Animate Diffusion with ControlNet to generate a stylized QR code video. While this approach improves video quality, the scannability remains poor. To address this, we drew inspiration from existing 2D QR code stylization methods and refined the generated QR code video. Finally, we achieved a result with smoother motion and significantly improved scannability. Now, let's dive into the QR code refinement process. To improve scannability, we draw inspiration from the previous QR code stylization method, ArtCoder. Specifically, we incorporate a code loss, which calculates the MSE loss between each QR code module in the original QR code and the stylized QR code. This ensures that the essential information in each QR code module is preserved, improving its scannability. In addition, to maintain the visual appearance of the result, we include a style loss and content loss between the optimized target and the original stylized QR code. These losses are computed using perceptual loss, which helps preserve the overall aesthetics of the QR code. After applying the QR code refinement process, we achieve results that offer excellent scannability while still retaining the desired visual appearance. Next, I will show some results of our apparack. We applied two different settings for our experiments. For general producing animated QR code and aesthetic comparison, we set the strength of our control net, which is used to guide the generated results closer to the QR code, to 1.8, while 1.1 for the scannability comparison. We totally generate 11 QR codes for comparison. This is our quantitative result of scannability and aesthetic comparison. We calculate the scanning accuracy, the appearance score, CLP-IQA, and the text frame similarity, CLIP similarity. In the first table, we can see that under close CLIP scores, the scanning accuracy of our method achieved 100%, while our baseline gets only 78%, which indicates our method is more reliable than the baseline under similar appearance. For the second table, it shows that under the same scannability, our method has a better appearance and can align text prompts and frames better. Here are some visualization comparison between results under different control net strength and different methods. We can see that the motion and appearance of QR code generated by our approach has significant improvement compared to AnimateDiff with ControlNet. These are more results generated by our method. Except for the results just shown, we also did some other experiments and made some observations. After completing our project, we conducted an extra experiment where we removed Animate Diffusion with ControlNet from our method. Interestingly, we found that the results were better than those from our full pipeline. We believe this is because the current implementation of Animate Diffusion with ControlNet is not yet capable of generating fully satisfactory results. That said, even without ControlNet, you can still see some QR code points and artifacts in the video. We think this shows a need for a better generative prior to fix these issues. So, while our full pipeline produces less optimal results, we believe that optimizing it with generative priors offers a promising direction for future work. Finally, let's summarize conclusions for our method. The focuses of our project are to explore methods for animating QR codes and enhance the motion of dynamic QR code while maintaining or improving the scannability. There are also some limitations in how we may do to tackle the problems in the future. For the appearance of QR codes, our approach still remains noticeable traces of the original QR code structure. We plan to apply more advanced optimization methods used in the SOTA studies and incorporate temporal loss constraints to improve the overall quality and consistency of the animations. Furthermore, our animated QR codes exhibit noticeable unnatural motions, which may be solved if apply more advanced video diffusion models such as Sora. QR codes play an essential role in daily life, enhancing their aesthetics, including developing animated versions, creates exciting opportunities in marketing, interactive media, and digital communication by combining visual appeal with practical functionality. Although there's still plenty of room for improvement in our project, we believe it represents a promising direction for future research.